Welcome to the File Management with Folders and Metadata video, which is part of the 7 Bridges onboarding lesson. As you watch this video, please keep in mind 2 key concepts. The first is that files can be managed, copied, moved, or put into a folder on the Cancer Genomics Cloud, just like you do on your computer. And the second is that using file metadata and tags will provide some key benefits for your project organization and data analysis. At the end of this video, you should be able to copy, that is, link files from one project to another, filter the files tab view multiple ways, create folders, edit file metadata, and understand some advanced metadata options. In the demonstration, I'm going to teach you how to customize the Files tab view, filter project files based on file metadata, link example.fastq files to a new project, and edit metadata of the files in the new project. First, let's look at organizing with metadata. Now I've switched tabs to the Cancer Genomics Cloud. And you can see I've got 2 projects in this. On my dashboard, I've got a couple of demo RNA-seq projects that I'm going to be using for these videos. We're going to be talking about 3 different ways of organizing and dealing with your files. These things are not mutually exclusive. You can use all 3 of them at the same time if you want to. So to start, I'm going to click into my project and go to the Files tab here in the second header. So what we see in my Files tab is that I just have all my files just here. The first thing I can do to sort through and filter my files is use these filters up here at the top. So one thing that you'll probably find yourself using a lot is filtering on extension. Let's say I just want to look at my FastQ files. I could click that drop down and click FastQ. And now the only files that I'm being shown are my FastQ files. The view here also changed. It added a column called Path, because when you start using filtering, it isn't going to try and respect any sort of folder structure you've made. It's going to filter and show you all of your files. So let's see if there are any other columns I might want to look at here. Maybe I want to add experimental strategy because I only want to be using RNA sequencing files, but unfortunately, experimental strategy is not filled out. So experimental strategy, task ID, size, sample ID, these are all metadata columns. All of the columns that you see here in the Edit Table Columns window are metadata columns. And metadata is very crucial to not just to being able to organize and sort your files, but it's also used by many apps on the Cancer Genomics Cloud to help with file processing. So for example, in this study, we are going to end up using this custom metadata key genotype to run DE-seq2 for differential expression comparisons. We can edit metadata fairly easily and quickly. One way to do it is you can click on the file itself, and rather than it opening that file for you, it's going to open a file view, which will show you the metadata. So I can click Edit Metadata, and I can add an experimental strategy. Experimental strategy is a controlled term. You have to choose it from a dropdown. We're going to pick RNA-seq. And I know that in my naming convention, _2 means that this is the second set of reads from a paired end experiment. So I can also click paired end here. Paired end is also controlled, and click 2. So that's one way that you can add metadata, but we can also go back to the files view. We can see that RNA-seq experimental strategy has been added. Here I want to, again, filter by FASTQ file extension. One quick note, if you have more than 100 files here, you should click this button and do select all, because otherwise it will only select the first 100, which are what are shown in this pane. So after I've selected all of them, then I can click Edit Metadata, and I can change experimental strategy for all of them at once to RNA-seq. Beautiful. But what about the paired end data? I can't change all of them at once that way. So I need to deselect these. And I'm actually just going to search based on file name _2.fastq. Now I'm only seeing the 15 files that have that _2.fastq in them. I'm going to select all of them, edit metadata, and say that they are paired end 2. Okay, and then I want to do the same thing. I'll clear the selection. Instead of doing _2.fastq, I will do _1.fastq. And now I, again, only have 15 files. Click that, edit metadata, set paired end 1, and hit save. So that was kind of just a quick overview of how you can edit metadata in bulk. Now let's look at organizing with tags. These files have tags attached to them. These tags are one of the things you can filter on in the filter dropdowns here. So if I click on tags, I can see that I've got a few different tags. One of them is index. That's that salmon archive. Another tag that I have is GRCH38, the human genome version 38. Both of these two reference files are GRCH38. And just to make it easier for me, I'm going to select both of them, click tags, and then I'm going to add a tag. I'm going to add the tag reference. So now both of those files are tagged with reference. Let's clear those filters again, and let's look at our things that don't have any tags. These are all FASTQ files. And in fact, just to be sure, I could also go ahead and filter by extension and filter to FASTQ. So now I see that I'm filtering for things that have the FASTQ extension and have no tag. I'm going to select all of them, and I'm going to tag them with RNA-seq. I've already added RNA-seq in metadata as part of the experimental strategy, but now I have RNA-seq as a tag as well. I'm going to clear my filters. Let's go ahead and add back experimental strategy just to see it. So you can see I've still got RNA-seq as metadata, and I've got RNA-seq as a tag. I really like using tags because they are completely customizable and personalizable. They really are ways for you to just put a little handle on your files so you can find all the ones that apply to a certain thing. You might even, if you wanted to make yourself a little tiny test data set, here I might take these top 4, which are the first and second paired end reads for my first 2 samples. I can just add a tag, test data. And so now I've just got a little handle on these files that will let me grab them as a small test data set. So now the last thing I'm going to show you is how to add folders. Let's see, I've cleared all my filters, not sorting on anything in particular. Let's sort on size just to have something different there at the top. So you can make as many folders as you need, and you can nest the folder structure. So I'm going to add a folder called input. And now how do I put things into that folder? Well, first of all, what is going to be my input? I know that my input files are all going to be FASTQ. I'm going to select all of them. And now I've got an option called move, and I'm just going to move them to my input directory. Done. So now I clear filters, and when I clear my filters, so that I'm no longer filtering all of my files, I see that I've got an input folder and I've got these two files still in my root directory. I want to put them in a folder called reference. So I'm going to use the tag that I made, reference, to select them both. And then I'm going to move them to reference. Excellent. Clear all my filters. And now this is my file structure. An alternate way to look at files, if you have folders, there is a sidebar. You can toggle that on with this button. And this sidebar will show you your folder structure. So another thing that is really good to know about files on the Cancer Genomics Cloud is we can copy them to other projects, or we can copy them into projects from other projects. So I'm going to do that actually both ways. I'm going to go into my input folder, and I'm going to add paired end, and I'm going to add a filter. So we can filter on any of the metadata that is attached to any of these files. I'm going to filter based on paired end status. I'm going to just take the second reads, the paired end number 2 files. That's only 15 total files. That makes sense. I have 30 input files. I'm going to select all of these, and then I'm going to click copy, and I'm going to copy these files to my other demo project. I don't have any folder structure in here yet, but I can add a new folder as I'm copying. So I'll add this new folder, input. And we also have the opportunity to add a tag to these if we want as we're copying them. I'm actually just going to remove the test data tag, and I'm going to add a tag input, just to add a tag. So now if I go to my project, bulk RNA-seq demo 2, and I go to my files, I will see that I have an input folder. So if I click on input, I'll see that I have all the files that I copied over here, which is just read 2 of each of my paired end samples. That doesn't actually make any sense to do, so I'm going to add files from a project, and this is where I'm basically going to be pulling files in from this other project. So I want all of those files in the input directory, and I'm going to copy them to project, and I'm going to add that tag input to them. So now if I go back to my demo 2 project, go to my files, and go to input. And what I'm going to find is that when I pulled those files in by clicking on that input directory, it retained the directory structure, moved that whole input directory into my current input directory. And that is not what I wanted. So to fix this, I will select all these files. I'm going to move them here to my first input file. Move all of them. And now this folder is empty. So I will go back to input and I can just delete that folder because I don't need it. However, look at what's happened. I now have 45 files instead of 30 files. And that's because the Cancer Genomics Cloud doesn't clobber your files. It tries very hard to maintain your files, and your files are immutable. So rather than try to overwrite anything, it made a new link to this file and prepended the name with _1_. That's helpful because it means I can search for _1_, find those 15 files, and delete those extra files. So be careful with deletion. Deletion is not reversible. Another thing that's important to note about copying files is that in many cases, it's not really copying. If two projects are on the same billing group as these two demo projects are, the files only actually exist in one location on the cloud storage. That means I'm only paying for storage once for these files. This is also true for hosted data on the Cancer Genomics Cloud, such as the TCGA datasets or public reference files. When you copy those into your project, a new copy of the file isn't created, you're just creating a link to access that file. However, changes in metadata don't mirror back to the original copy. Each linked file has its own metadata. To demonstrate that, let's go back to these two demo projects. So for example, let's say I want to take all of my input files, I want to edit my metadata, and I'm just going to add an investigation name. I'll just make that bulk RNA-seq and hit save. Now for my files pane, I can click add a filter, add investigation, and see that bulk RNA-seq is a piece of metadata that I can filter on now. But that will only be present in this one. If I go to bulk RNA-seq for demos and look at files, add a filter, and look for investigation, I won't find that metadata here. So some key takeaways from that. First, files can be managed, that is, linked from project to project, moved, or put into a folder on the Cancer Genomics Cloud, just like you do on your computer. However, using file metadata and tags provides several additional key benefits for organization and analysis and are highly recommended. Finally, files can be linked to multiple projects that share the same billing group without increased storage costs. That concludes this video. The next module in the onboarding lesson is the public apps gallery. Thanks for watching.